Hello everyone, in this video I'm going to discuss the example for vector. Kindly refers to the question, given two straight lines, we have the L1 and the L2. For the L1 we have the Cartesian equation, and for the L2 we have the vector equation. Shows that L1 and L2 are not parallel and find the acute angle between the two straight lines. So first of all, what we're going to do is to express the situation for the L1 into the vector equation. So kindly refers to the L1, we have x minus 1 equals to negative 3t. Negative 2, negative y equals to negative 8t. Then we have the z equals to negative 3t. This is what we have, the parametric equation. X is equals to 1 minus 3t. Y is equals to negative 2 plus with the 8t. Then z is equals to 0 minus 3t. So kindly express the situation in the vector form. So we have r is equals to bracket 1, negative 2, 0, plus we have t bracket negative 3, 8, and negative 3. So what we have the vector form. Next, kindly refers to the L2. We have the vector form as well, where we have r is equals to bracket negative 2, 0, and 4. Plus we have lambda 10, 10, negative 7. So kindly refers to A. Shows that L1 and L2 are not parallel. So how to show not parallel? Make use of the situation. We have vector V1, which represent the R1 or L1, cross with the vector V2, where we have the direction for the L2. So here we have I, J, and K. Kindly substitute the situation. Negative 3, 8, negative 3. 10, 10, negative 7. So here we have I, negative bracket, J, plus bracket, K. So kindly close up the I. Cross the J, K. So where we have negative 56. And then plus we have 30. Continue. Close up the J. We have 21 plus with the 30. Close up the K. We have negative 30 and then negative 80. So rewrite the situation, or we simplify the situation. We have the V1 cross with the V2, where we have negative 26, 51, we have the negative, and then we have negative 110. So notice that we have V1 cross with the V2. The answer is not equals to 0. Since the answer is not equals to 0, we can say that shows that the L1 and the L2 are not parallel. Next is to find the acute angle. So kindly refers to the situation. Here we have the formula. We have the magnitude. Vector 1 cross with the vector 2 equals to the magnitude for vector 1 dot with the magnitude of the vector 2, and then we have the sine theta. So kindly make use of the answer given. So here we have the square root. We have 26 bracket square plus we have 51 bracket square. Then we have 110 bracket square equals to the magnitude for the V1. Here we have 9 plus with the 64 plus with the 9. Multiply with, we have 100 plus with the 100 plus with the 49. Then we have sine theta. Can I simplify the situation? For the left hand side, we have 15377 equals to square root 82. Multiply with 249 and then sine theta. Continue. Theta is equals to where we have arc sine bracket. We have square root of 15377 over square root of 82 multiplied with 249. So from here, theta is equals to 60.21 degree. So that is the angle between the two straight lines. Kindly refers to B. Determine the intersection point between the L1 and the plane pi. So kindly refers to the L1, we have the vector equation and also the parametric equation. Next, kindly substitute the parametric equation for the line 1 into the equation plane. So refers to the equation plane, we have 2x minus y plus with the 5z is equals to negative 25. So kindly substitute the x. So 2, we have the bracket 1 minus 3t minus y. We have the situation negative 2 plus the 8t. Continue, we have plus 5z. So in here the z is negative 3t equals to negative 25. Kindly expand and then rearrange the situation. So here we have 2 and then positive 2 and then next we have the situation negative 6t, negative 8t, negative 15t plus with the 25 equals to 0. So in here we have 29 equals to, so if we sum up the situation, so here we have negative 29, rearrange the situation and we will have 29t. So from here t is equals to 1. Kindly substitute t equals to 1 into the parametric equation of the line for L1. So x will be equals to 1 minus 3t, so negative 2. Y is equals to, if we substitute 1 and we will have 6. Z is equals to negative 3. So from here, the points of intersection between the line 1 and the plane, where we have the point, the coordinate will be negative 2, 6, and then negative 3. Next, kindly refers to C. Find the Cartesian equation of the plane containing the L1 and the L2. So kindly reimagine the situation. Here we have the plane, and we have the L1 and the L2. So as we all know, for the L1, we have the direction and also the point. Same goes to the L2. So what we have to do is to find the normal for the plane, where we have to cross the L1 with the L2. So here we have the normal for the plane. Next, refers to the formula, we have R dot N equals to A dot N. So in here, we already found the normal. What we have to do is to make use of one of the point for the line L1 or L2. So kindly refers to the L1, we have the point in here. So here will be the point for the point A. So kindly substitute the situation. So x, y, z dot with the situation negative 26, negative 51, negative 110 equals to the point 1, negative 2, and 0 dot with negative 26, negative 51, negative 110. So negative 26x minus 51y minus 110z is equals to negative 26 plus with 102 and then 0. So kindly rewrite the situation, or we can say simplify. So here we will have 76. So negative 26y minus 51y minus 110z is equals to 76. That will be the Cartesian equation of the plane. Or we can write the situation 26x plus 51y plus 110z equals to negative 76. So that will be the Cartesian equation of the plane containing the L1 and also the L2. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.